exciting time because we are now moving into the real thing. It's, you know, in the last 2 weeks, I've been, guys, this is a video, remember. In the last 2 weeks, I have been focusing on foundations, things that we have to know in order to do this. We talked about the different types of numbers, whether they're natural numbers or counting numbers or whole numbers or integers or rational numbers or irrational numbers or real numbers or imaginary numbers. Remember that lecture?
Yes.
We talked about adding and subtracting positive and negative numbers. We talked about multiplying and dividing positive and negative numbers. We talked about order of operation. We talked about evaluating an expression when x equals this and y equals that. Remember all those things?
Yep.
Now we put it all together and we actually create what's called equations. And with those equations, we're going to solve for those equations. Okay? What we're going to talk about today is one-step equations, meaning it only requires one step to get the answer. Most of you will know the answer. When I put up the thing, you're going to immediately say, oh, I know what that is. Move on. We're ready to go. Right? No, the idea is I'm giving you something simple so that we can create a pattern, create a process that we can use every time, even when they are difficult. Does that make sense? So even though you will immediately know the answer to each one of these, or at least to the first probably two, maybe not necessarily to the third one, we're more concerned about the process. How do we go from what we have been given to getting the actual answer that says x equals this? Because that's our goal, is we're trying to find out what does x equal? What is the unknown variable equal? Whatever it's x, y, z, a, b, c, whatever it is. Okay? First of all, though, can somebody explain to me what is an equation? James.
A question?
It's actually the reverse. It's actually a statement, right?
Oh, yeah.
An equation is a statement. Lucas?
An expression with an equal sign on the end of it?
An expression with an equal sign on the end of it, but there's also got to be something on the other side, right? Right? After the equals, you have to have something there. Okay, Luke.
A number, a sign, and a number, and then another sign, and then another number. And that's more numbers than signs.
Okay. Right, okay, good. What does equal mean? What does equal mean, basically?
Isn't an equation just a problem with an answer to it instead of just a simplified equation?
Yeah, a problem with an answer to it. And ironically, within a problem with an answer to it, we can often simplify and go further and actually figure out what everything is in that problem. James, what does an equal sign mean? What does equals mean?
The same as.
The exact same as. I totally agree with that, right? So when I say this equals this, they're identical. What's on this side is identical to this side. Think of a balance scale, right? A balance scale.
Mm-hmm.
If I have the same weight on both sides, am I balanced?
Yeah.
Right? As soon as I take a little bit of weight off, say, this side, what happens?
You go down.
Right? It messes up my balance, right?
Yep.
So I always, if I'm going to take, the goal with an equation is always keep it balanced. Always. It's always horizontal. You never take something away from this side unless you also take it away from this side. Does that make sense? You've got to do the same thing to both sides. You never multiply this side by a number without also multiplying this side. Because if you did, if you multiplied this side by a number greater than 1, it would be out of balance again. Does that make sense? You've got to do the same thing. So there is a thing called the golden rule of algebra. Does anybody know what that is? Has anybody heard of that? Tess, what is it?
Whatever you do to one side, you have to do the other.
Yes, so it's so important that I'm actually going to write it down. So golden rule. Golden rule. And I'm going to tell you a different way that you can think of it too. Golden rule, got to make sure this is on the thing, of algebra. Is that on there? Huh, just barely. Okay, well, whatever. Golden rule of algebra. So basically, do unto one side as you would do unto the other. Do unto one side of an equation. In fact, I'm even going to do unto one side of an equation exactly as you do to the other. Okay? That's key. That is the foundation of everything you're going to be doing all year long. If you don't follow that rule, you won't ever get algebra, right? There's no way you're ever going to solve an equation. But today, you will know that rule. You will have that rule down pat. It's really important. Now, that's one way to word it. I've actually seen it worded a different way, which I kind of like as well. And it says, you can do anything you want to one side of an equation. Anything. As long as you're fair and you do the exact same thing to the other side. Right? I can have an equation. I can say x plus 2 equals 10. And I can say, oh, I want to multiply it times 100. I'm going to multiply this times 100, but I have to multiply this side times 100 too. Right? And then suddenly now I've got 100x plus 200 is equal to 1,000. Now I may have changed values, right? I may have changed the equation, but what did I not change? I didn't change the fact that it's balanced. Does that make sense? Right? And it's because of that that I can do anything I want. And then I could subtract 10 from this, right? Subtract 10 from both sides. And then I have 100x plus 190 is equal to 990, right? I changed it, but I maintained its balance because I did the same thing to this side that I did to this side. Does that make sense? So that's what an equation is. It's an always perfectly balanced statement of truth. Does that make sense? That's what an equation is. So, let me think. We were going to do that, and there was one other thing I was thinking of. I guess we'll just go ahead. We'll start with 1. Okay, so number 1. Let me just be sure that's on here. That is, okay. So 1. Let's say we have x plus 4 equals 10. And of course, now this is where everybody goes, oh, I know what it is. X is 6, right? Okay, so we know what x is 6. Okay, we have that out of the way. X, we got it. We got the answer. Now let's talk about the process. The process. What do you do to get x, to get an answer to find the value of x? So Dan.
So that would be
So now you're saying subtract 10 from 4. You mean the other way around. Subtract 4 from 10, right? Exactly. Now, Sienna.
You would subtract 4 from 10, but you, because when you do one side, you have to do the other. You would also subtract
Right.
the 4.
Right. Do you see that? You just left out that one piece. That's what you were thinking. You immediately said, oh, well, the way I get that number is I just subtract 10 minus 4 and I get 6. That's right. That's right. Okay, Lucas?
So the way that you want to solve it is you want to isolate the variable. And the way that you do that is you want to get that 4 out of the equation. So you subtract 4 from each
So
side.
here we go. This is really important. Here's our goal. We want to isolate the variable. Let's see here. Once you know that doggone thing is not. I wonder if I can just adjust this a little. Oh yeah, look at that. Why didn't I think of that earlier? Jeez. Okay, isolate the variable. Now what does that mean, isolate the variable? What is it going to say? How will I know that I've isolated the variable? Jan.
You get x all by itself on one side of the equation.
So it's going to either say x equals, or it's going to say y equals, or m equals, right? Whatever variable you're using, it's going to have that variable followed by an equal sign. You agree with me?
Yes.
That's when I'm done, right? That's when I'm done. So that's my goal. I have to isolate the variable. Now what if I had, well, we'll get to that. No, I'm not going to go there. Now, in order to isolate the variable, you have to look at it. I wanted to say x equals. What's in the way of it saying x equals? Rosemary.
The plus 4.
The plus 4 is in the way. You guys agree with me? If I didn't have that plus 4, it would say x equals, right?
Yep.
So I have to ask myself, what is 4 doing to the x? It's adding 4 to the x, right? Last night, this pisses me off too, because last night x was all by itself. I was very, very specific when I left this school to make sure that x was by itself. And somebody in the middle of the night came in and they added 4 to that x. Can you believe it?
Yeah.
Oh.
Oh my god.
So,
It was me.
so how do I undo what they did?
You take
So,
that 4 right
Gardner,
away.
I want to undo. They added 4. How can I undo adding 4?
You add negative 4 to the positive 4.
Okay. So I noticed the operation that they used was addition, right? So I'm going to use the opposite operation, which is subtraction. So I'm going to put a minus sign underneath the plus sign, and I'm going to put a 4 here. Now, I have just done this.
Whatever you do to one side, you have
I've got to do it on this
the other.
side too, right? So suddenly I have x. Now notice 4 minus 4 is? Now, do I have to write plus 0?
No.
0 is nothing. So I don't have to put it, I don't have to write a 0 here. I just have x equals 10 minus 4 is 6. In one step, we use the opposite operation on both sides. Does that make sense?
Yes.
And we got the answer. And I know some of you know this like backwards and forwards. I get that. Right? But it's just the process right now we're focused on. Stacey.
Can't we just use mental math and just say
No.
sixes? Yeah,
No.
but
I mean-
basically, when you have like big problems,
Yeah.
how are you going to use mental math?
Yeah. That's why we're doing it, Stacey. It's because these are easy. Yes, you could use mental math on these, but that's not what I'm asking. On everybody's homework tonight, guys, on everybody's homework tonight, I'm expecting to see the one step you did to get to the answer. I don't care about the answer. We all know what the answer is, right? I care about this part. I want to see this on your paper. I want to see this step. Notice I drew this line underneath. After I subtracted 4 from both sides, I drew a line underneath it. I want to see that line.
Okay.
Is that clear?
Yes.
So I want it to look exactly like this. When you get to high school, some teachers, if you put an answer, I don't do this, but if you put an answer on if you just said x equals 6, and you did mental math, you know what he'd do?
You said wrong.
He would pick it up. I said, oh, that's nice. Do it again. Right? Right? And that's what he do. And so, I've talked to dozens of students that have had that happen to them.
You should have put it in the recycling bin.
You're right. Well, I don't know where he
Mary, how dare you?
You're evil!
I'll remember it. All right. So this is really easy. Got bad teacher. Okay. So let's try another one. Just be sure we've got the process down. Let's say we have x minus 7 equals 12. All right. X was all by itself last night. Somebody came in and subtracted 7 from it. Made me mad.
It's me
Right?
again.
And we have to undo the subtracting 7. So, Jan, what'd you do?
You would add 7
Add 7.
to both sides.
Whatever I put here has to be the opposite sign of what's there. If it says minus there, it's got to be plus here. 7. And then I follow suit over here and do the same thing. And then suddenly x, this is 0, right? That crosses
0
out,
and 19.
is equal to 19.
Yeah.
Okay? Let's do one more. Let's say I gave you this.
And you can always check your problem by plugging in the number you got for x. Yeah, but I'm too lazy to do that.
Okay. All right, here we go. We got x plus 28 is equal to negative 12. Now suddenly it's a little harder. Do I care about the negative 12?
No.
No.
What's the only thing I'm looking at?
The 20.
X.
Lucas.
28.
The 28. That's adding to the x. I don't want that to be there. So I am going to subtract 28, right? So I'm going to do minus 28. Minus 28. Now we are using our rules, right? We're using our adding and subtracting positive and negative numbers rules, right? That we learned. Okay, this crosses out, right? So immediately I have x equals, now I have a negative 12. Here's my number line. Negative 12 minus 28. Right?
Negative 40.
Negative 40. I keep the, when the signs are the same, I keep the signs and I add the numbers because they're both going to the right, or to the left, excuse me. To the right to me, right? To the left for you, right? They're both going to the left of 0. So it's going to be negative 40. Okay. Fist of 5. You guys get it?
Yes.
Okay, awesome. All right.
Oh, very funny.
Here we go. So that is a one-step equation, right?
Wow.
It just takes one step to solve it. Now let's see a different type of a one-step equation that you might see. I don't like the way I'm numbering these. I'm going to number this as a 1, 2. Is that okay? That way, this is a different one, right? Different type. So if, let's say we had 4x equals 20. Now, my guess is most of you immediately thought, well, let's see, 4 times what is 20? Oh yeah, 4 times 5 is 20. Ah, x is 5, right? Okay, x is 5. Great. We got that out of the way. Now let's think about our process. So Mushi.
Since it's the same rule, whatever the equation, you have to do the opposite of. So since it's multiplying, we have to divide.
What's multiply?
What the 4 times x? That's
The numbers touching the variable.
Oh, when a number touches a variable, it doesn't have an operation at all, right? It doesn't say plus or times or minus or divide by.
Like
You
coefficients.
assume multiply, right? I've explained this, I think.
Yes.
Too many times.
It's a coefficient.
So it is. So it's a coefficient. And all that means is this. This is what it really means. X plus x plus x plus x is equal to 20.
Or X.
Thank God for algebra, because algebra is all about shortcuts, right? If we didn't have algebra, we would be writing it like this, right? It would be a mess, right?
Well, without multiplication, we'd be doing that.
Yeah.
Right, right. Okay, so Mushi noticed that the operation here is adding. The operation here is subtract. The operation here is adding. The operation here, though, is multiply. What's the opposite operation of multiply? Divide. Now, I have seen people do this, and I do not recommend this. In fact, I won't allow it, okay? I just want to be clear. I've seen people do this. They go like this. Divide by 4, divide by 4.
No.
Even though, guys, even though that is okay and it's true and it's accurate, that it shows it requires more work than creating a fraction, right? Every fraction is a division problem, right? And so by doing it this way, it makes way more, it's easier and it's easier to solve. It's easier to manipulate a little bit. So I see I've got 4 times x. I'm going to divide by 4, so I'm going to put a division sign right there like that. Just a line, because every fraction line connotates a division problem, right? So suddenly I'm going to put my 4 downstairs, but I just did, what did I just do? I just did this, right? I've got to do it to both sides, right? So I've got to do it, I've got to divide by 4 on that side. So 4 over 4 is?
0. It's a 1.
1. Right. So it's just 1x. Do I have to write the 1 in front of an x?
No.
If it says 1x, if it's 1x, it's the same as just x. Okay? Because x is a variable, 1x is a variable, right? 2x's is 2 variables, right? 1x is a variable. That's it. That's my x. Equals 20 divided by 5. It's upstairs divided by the downstairs, which is 5.
You said it's divided by 4, not 5.
Sorry, divided by 4 equals 5. So that's the problem. When you know the answer,
Now I
sometimes...
wrote x equals 4.
Oh, all right, so that's pretty easy, right? So simple. Okay, let's try another one.
Gary,
Oh,
Gary.
Yes.
Oh, you didn't put that line that you put on the other ones.
That's because
Yeah, but that's
every
because
time I put problem.
Oh, yeah.
And this, yes, when you're dividing, good question. That's a great question. When you're dividing, the line is there, And I'm not putting it under the whole thing. I'm putting it just under this side and then once under this side. Okay? That's how I want to see it for now, right? There are shortcuts, but some people will probably do. But for now, that's the easiest, the best way to do it. So what if I give you this, though? Negative 3x is equal to negative 15. Suddenly, you're going to use your positive and negative numbers. Positive and negative numbers. So I want my x. My goal is always to isolate the variable. I want x to be all by itself. So Lucas, help me.
So you can divide both sides by negative 3.
Right. Now, why not just 3? Why do I have to do the negative 2?
Because if you didn't, then you'd be multiplying by a number that's not in the equation.
Correct.
Dividing.
So whatever is in front of the x is what you put underneath. If it's got a negative, the negative goes with it, right? Because remember what I'm trying to do is I want it to say 1x, right? I don't want it to say negative 1x. I want it to say 1x. So negative divided by negative is a positive. 3 over 3 is 1, so that's just 1x. Well, wait a minute, I got to do it on this side too. All right, so now I suddenly have an x. That immediately crosses those out, right? Equals, whenever I see a negative upstairs and downstairs, I just go like that. Immediately it turns it into a plus, right?
Yep.
And so it's just 15 divided by 3, which is 5. Oh my gosh, you guys, are you seeing a pattern?
Wow.
Whenever you divide by a number, you get 5.
No, Gary, no.
No,
Not
Gary.
how
This
it
is
works.
brilliant.
Not this again.
Okay.
Not how it works.
Divided by 4.
All right, just to 5. Are we clear on this?
Yeah.
Do I need to do more examples?
No.
Okay, good. All right.
The golden rule. How dare you erase the golden rule?
Oh, it's not so golden anymore.
Now what are we
It's a bronze
I didn't
rule.
tell anybody I did that. All right.
It's a bronze rule now, guys.
Bronze rule.
No, it's silver.
Okay, guys, we're almost done. We're almost done. There is a third type of one-step equation.
Ah.
Okay? A third type of one-step equation.
Another one.
Another one. And then another
Oh, of
one.
course.
Oh, yeah.
Forgot about division.
I know how to throw it.
Over there.
Okay. 2/3 x equals 10. So, Jan, what would you do?
Okay, so you would still just divide by 2/3, and then that would just cross out and be 1, and you don't have to write that. And then you do it to the 10, and you put 10 over 1, so it'd be 10 over 1, and then you divide them, because
Okay.
it's the opposite, and then you flip the 3 and the 2. So
Okay.
What?
You're right. You're totally right on. Totally right on. So I just want to make I want to add to what he's saying because he's totally right. When you have, this is it really in all honesty, this is the same thing as this. Do you see that? There is a coefficient in front of the x equals a number. A coefficient in front of the x equals a number, right? It's really the same thing. The only problem is that is a fraction in front of the x, right? And so, if you go like this, that's confusing. Do
Yeah.
you agree with me?
Yeah.
That is confusing. And so you have to remember that's not how I would suggest you do it. Think about this. If you're dividing 2/3 into 2/3, how do you do it? How did you learn how to do it? Lucas.
So what you do is you find the
Guys?
multiplicative inverse of the second number, which is basically you flip them.
Okay.
The
So
reciprocal.
the reciprocal or multiplicative inverse, right? Same thing. They're the same thing. Just one's easier to say.
Multiplicative inverse.
But it's totally right. It's totally right. Remember the copy dot flip idea? Copy dot flip. Always turn a division when you have fractions and you're dividing fractions. You always turn it into a multiply problem. Always. Yes. So immediately I copy it. 2/3 times 3/2. Right?
Oh, really?
And when I do that, what happens?
Crazy.
I get 6 over 6, which is 1. So that's a rule. That's actually a property that I probably should have put into yesterday's lecture, which is the multiplicative inverse. Let's see. Property. They always have different names depending on what book you read. So the multiplicative inverse. Basically, the idea is the property is that any fraction, if you multiply any fraction by its reciprocal, you will always get 1. And that's my goal, right? I want to say 1x. I don't want to say 2/3 x. So I want to multiply 2/3 by its reciprocal so that it becomes 1. Does that make sense? Yes, Sienna.
In 6th grade, our math teacher taught us a song
Oh, really? Cool.
that goes, when dividing fractions, please don't cry, just flip the second number and multiply.
Oh, cool. That's awesome. That's awesome. I gotta remember that. So, instead of dividing by 2/3, which is really, this is what Jan was doing in his head. He immediately knows to divide by 2/3 is multiply by 3/2, right? But instead of actually writing divide by 2/3, I'm going to immediately say, let's multiply it times its reciprocal. Multiply it times its reciprocal. Okay? Both sides. So suddenly the 2's cross out, the 3's cross out. All I have left is x equals
15 over
30 over 2, which is 15, right? 30 over 2, which is 15. Okay? The way I do it is I simplify first before I actually, I don't just go
Really?
10 times 3, because then it could be a big number. I don't like that. I like to keep it
I want to
simple.
write this down. This
2
is
goes
way
into 2
easier.
once. 2 goes into 10 5 times. 5 times 3 is 15. So that's what I would have done. X is equal to 15. Let's try another one. So we've got
That was way.
negative 4/5 x is equal to 8. Negative 4/5 x equals 8. What is the number in front of x? Negative 4/5. What is the reciprocal of negative 4/5? Negative 5/4. If this is negative, the reciprocal has to be negative. So it's this times negative 5/4, right? And then times negative 5/4. Okay? And that's 8 over 1, right? So the 5's cross out, the 4's cross out, the negative times the negative becomes a positive. All I have left is x here. And then 4 goes into 4 once downstairs, and upstairs 4 goes into 8 twice. So my answer is 2 times negative 5, which is negative 10. Did I get, does it make sense?
Kind of.
Yeah.
Kind of? You see what I did?
Wait,
By using the reciprocal that's a negative, if this is negative, by using a reciprocal that's negative, it immediately becomes positive. Right?
Yeah, okay.
All right, and then I had a positive 8 here times a negative. I know the answer is going to be negative, right? You know, if you think of the signs separate from the numbers, it's sometimes easier. Then you won't get the signs mixed up. Jan, and then Luke.
So if it was, because you changed it from negative 5/4 to negative 5 over 4.
Ah, great question. Great question. Okay, I couldn't remember if I explained that to with you guys earlier or not. But this is that's a great question, because I find seniors in high school don't know this, and it's so important to understand. Negative 5/4 is also negative 5/4, which is also 5 over negative 4. Those are all identical. Because how many negatives does each fraction have? 1. That one negative makes the whole fraction negative. So you can put any negative anywhere you want in the equation, in the fraction. Does that make sense?
Yeah, but wouldn't the answer be different if you had negative 5/4 instead of negative 5 over 4?
No.
Because if
Because-
negative 5/4, then
So
the
look.
5 and the 4.
So if you got 8 over 1 times negative 5/4, right? I know positive times negative is negative, right? There, and then again, 4 goes into that once, 4 goes into that twice, so then it's 2 times 5, it's negative 10, right? If I did 8 over 1 times, you said negative 5 over 4? Okay, well, let's just do it. Let's just do it this way. So 4 goes into 4 once, 4 goes into 8 twice. I've got 2 times negative 5, that's negative 10. right? See what I'm saying? The negative just makes the whole fraction negative, right? Now it's not, negative 5/4 does not, you guys know that symbol?
Yes.
Does not equal this, negative 5 over negative 4. That is positive 5/4, right? Because it's a negative divided by a negative. It's a positive. Luke and then James.
I found a pattern. They are all multiples of 5. Bang.
Oh my God. And they're multiples of 1.
Exposed.
They're multiples of 5 and 1.
They're multiples of 1.
Oh my God.
Mind blown.
Alright. Alright. Fist to 5. You guys feel like you got this a little bit? Alright. So I'm going to end the lecture and we'll move forward from here.
5